Welcome to today's video on Unit 8, Part 2, talking about the Pythagorean Theorem. And we've talked a little bit about the Pythagorean Theorem in other sections, but remember the Pythagorean Theorem is in a right triangle. The sum of the squares of the two legs, because remember the legs make up the right angle, and then the hypotenuse is opposite the right angle. So the sum of the squares of the legs is equal to the square of the hypotenuse. There are a couple things called Pythagorean triples. That's when you do the Pythagorean theorem and all the numbers are whole numbers. Some common Pythagorean triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. That means 7 squared plus 24 squared equals 25 squared. And any multiples of those work. So that's why 6, 8, and 10 also work, because that's 3, 4, and 5 reduced by 2. So if you're looking here to find the length of a side in a right triangle, you can use the Pythagorean theorem, say x squared plus 8 squared equals 12 squared. So x squared is plus 64 is equal to 144. Subtract 64. X squared equals 100, or sorry, not 100, but 80. And then x equals the square root of 80, which is the same as saying the square root of 16 times 5, which is 4 rad 5. So for the next one, it's x 24, 26. So if you know it's a Pythagorean triple, a 5, 12, 13, you could say that it's 13. But if you don't, then you could say x squared plus 24 squared equals 26 squared. And then x squared plus 576 equals 676. So then when you subtract, x squared equals 100. I should have said 10, not 13. So x equals the square root of 100, which is 10. So number 15, so now you have x squared plus 36 squared equals 39 squared. And this could be a 5, 12, 13, because notice it's 12 times 3 is 36, 13 times 3 is 39, so 5 times 3 would be 15. But if we do the math still, we get x squared plus, well, 36 squared is 1,296. 39 squared, 1,521. When you subtract, you get 225, and you take the square root of 225, which is 15. And then last but not least, here you would have x squared plus 6 squared equals 12 squared. So x squared plus 36 equals 144. So when you subtract, you get x squared equals 108. So now x is equal to the square root of 108, and that is going to be 36 times 3. So that means it's going to be 6 rad 3. So here, a 20-foot ladder is placed against a building to reach a window. So here's your building, and here's the window right here. And the window is 16 feet above the ground, and the ladder is 20 feet. And any building makes a right angle with the ground. It wants to know how many feet from the building is the bottom of the ladder. So you put x. So x equals how far away from the building the ladder is. And so you do the Pythagorean theorem here, and you get 16 squared plus x squared equals 20 squared. 16 squared, you could either recognize it's a 3, 4, 5, and you know that x is going to be 9, or sorry, x is going to be 12, because 4 times 3 is 12, because all of these are divisible by 4. Or you could do the Pythagorean theorem, and 16 squared is 256 plus x squared equals 400. Subtract 256 to get 144. So then take the square root and you get x equals 12. So it is 12 feet from the bottom of the ladder to the building. Looking at the next one, a 10-foot ladder is placed against a building. The base of the ladder is 6 feet from the building. How high does the ladder reach on the building? So doing the Pythagorean theorem, so you get x squared plus 36 equals 100. Subtract to get 64, take the square root, and you get it's 8 feet. All right, so the Pythagorean theorem can also be used to determine what type of triangle you have, if it's an acute or an obtuse. So if you do the Pythagorean theorem and c squared, the hypotenuse, is less than a squared plus b squared, the triangle is acute. If you do that, c squared, and it's greater than a squared plus b squared, then it's obtuse. And obviously if it's equal to a squared plus b squared, then it's a right triangle. So if you were given the sides 10, 11, and 13, so you want to figure out if it's acute, right, or obtuse, well, 13 squared, you have to determine how that compares to 10 squared plus 11 squared. So 169 compared to 100 plus 121. So that means it's less than, because that's 221. So this means it's an acute triangle. So 14, 18, and 33. So you have to determine if 33 squared, how does that compare to 14 squared plus 18 squared? Well, 33 squared well, first, we have to determine if there can be a triangle. And notice 14 plus 18 is 32. That is not greater than 33. So therefore, it is not a triangle. Whereas here, 10 plus 11 is greater than 13. So we know that it can be a triangle. So here, 7 plus 8, that is greater than 14. So yes, it's a triangle. Now 14 squared compared to 7 squared plus 8 squared. Well, 14 squared is 196. Then you have 49 plus 64. So 49 plus 64 is 113. So 196 is greater than, so this is an obtuse triangle. So here it says to find x using the Pythagorean theorem. So we're going to go x squared plus 7 squared equals 12 squared. So x squared plus 49 equals 144. Subtract 49. X squared equals 96. 95. So then when we take the square root, we have to simplify it and see if any perfect squares go into 95, and the answer to that is no, so we can leave it as the square root of 95. So here, x squared is x is the hypotenuse, so x squared is equal to 13 squared plus 38 squared. So x squared is equal to 169 plus 1,444. So when you add those together, you get 1,613. There's no perfect square that goes into it. So when you take the square root, you can leave it as 1,613. All right, so that concludes our video on part 2. Actually, sorry, it does not. We still have one more page left. So here we're going to take a look using two different methods, determine whether triangle QRS with vertices Q, R, and S is a right triangle using slopes, and then using lengths. So using slopes, we would want to find the slope of QR, because I would graph it. So here's Q, R is 0, -1, and S is 4, -1. So it would look like this. So you want to find the slope of QR, which is -1 minus -3 over 0 minus 2. So it's 2 over -2, which is -1. Then we would want to find SQ. So it's -1 minus -1 over 4 minus 0. So it's 0 over -4, which is 0. And then we want to find SR, which is, actually, sorry, that's what I just found was SR. Then we want to find SQ. So SQ is -1 minus -3 over 4 minus 2. So it's going to be 2 over 2, which is 1. So the answer is yes, it's a right triangle. And the SQ is perpendicular to QR because they're opposite reciprocals. So SQ, QR. So that means Q, angle Q, is a right angle. Using lengths, so if you want to find the length of SR, remember that's the distance formula. So SR is -1, or sorry, distance formula x2 minus x1 squared plus y2 minus y1 squared. So it's the square root of -2 squared plus 2 squared. So it's the square root of 4 plus 4, which is the square root of 8. And then you have QR, which is 0. Sorry, I just found QR. I don't know what. Sorry, that was QR that I just found. SR is going to be -1. Sorry, x2 minus x1. So 4 minus 0 squared plus, and then y2 minus y1. So -1 minus -1 squared. So it's going to be the square root of 4 squared plus 0 squared. So it's just going to be 4 because it's the square root of 16. And then last but not least, I need to find QS. And that's going to be, from Q to S, it's going to be 4 minus, it's going to be 4 minus 2 squared plus, and then y2 minus y1, so -1 minus -3 squared. So it's going to be the square root of 2 squared plus 2 squared. So it's also going to be the square root of 8. So if you take the Pythagorean theorem and go square root of 8 squared plus square root of 8 squared equals 4 squared, well, the square root of 8 is just 8 plus, our square root of 8 squared is just 8 plus the square root of 8 squared is 8 equals 16. So since a squared plus b squared equals c squared, it would be a right triangle. All right, so determine whether 16, 30, and 33 can be sides of a triangle. Why don't you do the last three on your own, and then we'll go over the answers. All right, so for 25, 16 squared, or 16 plus 30 is greater than 33, so it's a triangle. And then when you compare 33 squared to 16 squared plus 30 squared, it is less than that, so that means it's acute. The next one, 13 eighths is the largest one. So therefore, 5 eighths plus 3 halves is greater than 13 eighths, so it's a triangle. And then when you compare it, 13 eighths squared compared to 5 eighths squared plus 3 halves squared, it's actually equal, because if you look, 9/4 is the same as 16, 1, because 4 goes into 64 16 times, so 16 times 9 is 144. So it's the same as 144 over 64, which means they're going to be equal, which means it's a right triangle. And then last but not least, which of the following lengths are lengths of an acute triangle? So you have to compare, well, if number 1 is a right triangle, and number 2, 8 squared, that is less than 4 squared plus 7.5 squared if you do the math. So therefore, it is an acute triangle. All right. Hope you enjoyed part 2. Part 3 coming up soon.